Okay, for this problem, we're looking at an integrand that has a y to the negative 2 and an e to the 1 over y. And for me, I see an e to the 1 over y, and I instantly think to myself, what if u equals 1 over y? Well, then that would imply that du equals negative 1 over y squared. And then I look, and I'm like, aha, that's good, because I have a y to the negative 2, and so I can think of negative 1 over y squared, of course, dy. And so I'm going to solve this for the parts that I have. So I have a negative y squared dy, or y to the negative 2 dy, and so I'm going to rethink this as just negative du equals y to the negative 2 dy. And so for my y to the negative 2 dy, I'm going to plug in a negative du. So I'm going to rewrite this, and I'm going to do it without the bounds for the moment, as negative du times, well, let's write it as just a negative e to the u du. Okay, and take the antiderivative of that. I'm just going to get negative e to the u plus c. And then if I want to put the bounds on it, I'm going to substitute the u back in. And so it's going to be negative e to the 1 over y. And then I'm going to evaluate that from the natural log of 2. And then I can't go to 0, so do the limit as a approaches 0. And then go from natural log 2 to a. And I can't do the 0, of course, because if you plug 0 into this right here, you're going to divide by 0, which you cannot do. So now I just need to evaluate that. So the limit as a goes to 0 of negative e to the 1 over the natural log of 2, and then minus negative, and of course, it's going to be positive then, 1 over a. And if I go to evaluate this, it's a little tricky to look at here, but e to the 1 over the natural log of 2, if you're asking yourself what that is, you could kind of just think through it. But you're going to get essentially something that's approximately 4.23, and then plus, and the key here is e to the 1 over 0 is going to be e to the approximately infinity, which of course is just going to be infinity, which implies that it diverges.